We talk about Sherlock being a board level reliability tool, and the board is obviously very important because it contains all of our parts and components and connects them to the outside world. So the next input we're going to look at, which is required for an analysis, is our board. All of the board properties is contained within our circuit board under inputs as our stack-up data. And if you double click on this stack-up data, you'll see the stack-up open up here. The stack-up data contains all of the layers that make up the board, as well as all of the mechanical information about them. But where does this information come in from? Well, this information is read in when we read in our ODB++ archive. And you can see, if I look under files here, which are the raw inputs that came in with that archive, you can see 6 copper layers. If I double click on one of them, for instance copper01.odb, you can see within the Sherlock layer viewer that this copper layer can be graphically visualized for us right here. And we can see that the green area is the copper area, and the white area is the area where there is no copper on that layer. Sherlock is able to not just generate a picture for this layer, but also analyze this layer and come up with a percentage of copper composition, which we can see here in our first layer. So what Sherlock has determined is that in this particular layer, copper makes up about 15% of the layer. And because of that, it has calculated this specific CTE value for the XY direction, as well as this CTE value for the Z direction for that particular copper layer. It's also calculated modulus in the XY and in the Z direction also. If I switch to my next copper layer and I look at copper layer number 2, we can see from this picture here that there's a lot more copper on this layer. And if I look back at my stack-up data and look at my second copper layer, we can see that Sherlock's determined the amount of copper on this layer to be about 94.8%. And because of a much higher copper composition, you see that the CTE and the modulus values have also changed to reflect that. So Sherlock has gone through and done this for every single layer. It's calculated CTE and modulus values for every single layer, as you see here, and also summed them up and come up with the aggregate CTE and modulus for the board as a whole. And that is represented here at the top, where you can see the CTE in the XY and the Z direction. Up the top here, we also see other board properties. So our board dimension, board thickness, the number of conductor layers, our board weight, and our part weight, all summated at the top here. With these stack-up layers, we can also edit information as well. So if I right-click on a layer, I can go to Edit Selected Layer and actually change that particular layer. So for layer 1, if I don't agree with this copper composition of 15% that Sherlock's come up with, I can change that. So I can say, you know what, I want it to be 22%. If I hit save, you'll see that these engineering properties have now changed, and that change is also reflected on the board as a whole. If I want to change it back to the original value that Sherlock calculated, all I have to do is click this button down the bottom here, update copper. Sherlock will run through again and recalculate the copper composition on that layer, and once again we get 15%. I can also change my copper layers or edit my laminate layers as a whole. Down the bottom, if I click select conductors, you'll see that all the copper layers have been selected. I can then right click and choose edit selected layers to edit all my copper layers in one go. Similarly, I can do the same thing for laminates by clicking select laminates, and I can right click, edit select layers, and change my laminate for the whole board. What I can also do is export the stack-up data outside of Sherlock also. Like any data in Sherlock that appears as a table, if I right-click and go to Export Stack-up Data, I can export all of this data as a CSV file or as an Excel sheet that can be used somewhere else or further down the line.